So, hello and welcome to lesson 9 of our study of optimization 1. So, in this video, we will talk about the Fibonacci search method. I'm Budo Randolph, a final year student of mathematics, KNUST, and I'll be taking you through today's lesson. Please don't forget to like the video and subscribe to the channel for more content. So, the Fibonacci search method is used to minimize a unimodal function f of x on an interval AB. So what do we mean by a unimodal function? Okay, so a unimodal function is a function which has just one turning point, okay? And the Fibonacci search method makes use of the sequence of the Fibonacci numbers for placing the experiment. And that means before you can really understand and know how to use the Fibonacci search method, you have to know how to generate the Fibonacci numbers. So let's briefly talk about the Fibonacci numbers. So the Fibonacci numbers are defined as follow. Okay, so we have f0 to be 1, f1 to be 1, and from there we have f subscript n plus 1 is equal to f subscript n plus f subscript n minus 1. So for instance, when n is from 1, 2 to 3. So when n is 1, we will have f1 plus 1 will be equal to f1 plus f1 minus 1, which is same as f2 be equal to f1 plus f0. So f1 is 1, f0 is 1, and that gives you 2. So that means f2 is 2. So that's how we generate them. So the Fibonacci numbers are what you can see here. So you can see this is f0 is 1, f1 is 1, f2 is 2, f3 is 3, f4 is 5, and it goes on. Okay, all right. So we use this relation here to generate them. So someone will ask, what is the algorithm for the Fibonacci search method? So one thing that I want you to notice is that there are several algorithms which is used to implement the Fibonacci search method to optimize unimodal functions. Okay, so we have several of them. When you watch different videos, when you read different textbooks, you realize that they all use the same concept, but the algorithm differs. But at the end of the day, they are all based on the same concept. Okay, all right. So because of that, let us go through how the method works generally. Okay, so that irrespective of the algorithm you use, you will know what you are doing. Okay, so the main task here is that we want to maximize or minimize a unimodal function f of x on an interval AB. So in doing this using the Fibonacci search method, what we do is that we divide the initial interval AB into fn sub intervals. Okay, so this fn here is a Fibonacci number. So after doing that, we choose two initial points, say xl and xr, such that we have something like this. So this is our interval AB, and we are choosing two initial points in it. So we have our xl here and xr here. Okay, and our xl should be less than our xr. So after choosing those 2 points, actually we have formula that we are going to use to get our SL and our SR. Okay, But now we are going through the general approach. So after that, we'll implement that using one of the algorithms. So after getting our XL and our XR, we then compute f of XL and f of XR. So we compute these two functional values. Okay. So after getting them, then we make a decision. So for a minimization problem, let's see if we are minimizing. Okay, if our f of XL that we computed is less than our f of XR, okay, then what it means is that at that point this is the minimum. So we are going to have something like this. So that means you are going to discard this part. Okay, so when we discard this part, that means that for the next iteration, our new A will be the old A, and our new B will be what? XR. So that's what you can see here. So we set A new to be equal to A and B new to be equal to XR. Okay. Then we go back to this place where we find XL, XR, and we continue doing the iteration until we get an optimal solution. Then if our f of XR is less than our f of XL, then that means that the minimum is somewhere here. So we are going to have something like this. So we discard this region. So that means that our new A will be XL and our new B will be the old B. So that's what you can see here. And we come back to this step to get our XL and XR, and that helps us to continue with our iteration. Okay, so that's the general approach, the general thing we're trying to do. Okay, so now let's choose an algorithm to do that. Okay, and we are going to choose this algorithm based on what we've done in class so that it becomes very simple for us to understand. So for a predetermined number n of search points and a predetermined epsilon, the Fibonacci search method for finding the minimum of a unimodal function. I hope you remember what a unimodal function is. It has one turning point. So over an interval AB can be summarized as follows. Okay, so this is the algorithm. We set A1 to be A and we set B1 to be B. Then we compute L1, and L1 is equal to B1 minus A1. Then step 2, we compute L2 using this relation here. After doing that, in step 3, we let XL, the one here stands for like we are doing first iteration, be equal to B1 minus L2, and we let XR, that the first iteration, be equal to A1 plus L2. Okay, so after that, in the fourth step, we evaluate f of XL1 and f of XR1. So after doing that, our L3 is giving us L1 minus L2. Okay, then based on the functional values we had, we make some decisions. Okay, so if our f of xl1 is greater than f of xr1, then we have this here. So our a2, so let's draw it here. So we have a, we have b, and we have xl1, xr1, right? So we are trying to minimize. So if f of xl1 is greater than f of xl1, that means that the minimum is somewhere here. So to be something like this, and we discard this region. So our new a2 will be this, and our b2 will be b1. So that's what you can see here. And our xl at the second iteration will be the xr at the first iteration, and we also have this. Don't worry, we'll implement it with a question. So after that, you go back to step 7. Next, step 7. And if your f of xl1 is less than f of xr1, then this is what you do. Okay. All right. So now let's take a question. So the question says that use an 8-point Fibonacci search with epsilon equals 0.00100001 to find the minimum of the function f of x equals x sine 1 over x over the interval 1 over 2 pi, then 1 over pi. Okay, so from the question, we are using an 8-point Fibonacci search. That means that our n is 8. Our epsilon is 0.001. Then the objective function here is x sine 1 over x. Then our a1, our a, which is the same as a1, is 1 over 2 pi. And our b, which is the same as b1, is 1 over pi. So after doing that, we have to construct our Fibonacci numbers, right? With n equals 8. So it will be 1, 1, 2, 3, 5, 8, 13, 21, 20, 34. So I told that you have to know how to construct that. We have discussed that in the earlier part of the video, right? Then this means that f0 is 1, f1 is 1, f2 is 2, f3 is 3, f4 is 5, f5 is 8, to f8, which is 34. So now from the iteration, the first step says we should compute L1, and L1 is equal to B1 minus A1. Okay, so B1 is 1 over pi, and A1 is 1 over 2 pi. So 1 over pi minus 1 over 2 pi will give you what you can see there, and that happens to be L1. So in step 2, we compute L2 using this formula. So in the question, our n was 8. That means n minus 1 will be 7. So we will have L2 be equal to F7 L1 over F8 because n is 8. Then plus minus 1, n is 8, power 8. Then epsilon is 0.001. Then over F8. But note that this is L1. And from the Fibonacci number that we constructed, our F7 is 21 and our F8 is 34. So we can make that substitution and we'll have this. Okay, and computing this will give us L2 to be 0.09830452368. So now we have our L2. So now the next thing is to compute our x left and x right, right? So XL and XR. And XL is given by B1 minus L2, okay? and B1 is 1 over pi. Then this is L2. So when you compute that, you're going to get 0.2200053625. Then we also have to compute XR at the first iteration. That one is given by E1 plus L2. And E1 is 1 over 2 pi. And this is L2. So when you sum them, you get this. So now we have XL and XR. Alright. So in the step 4, what we do is that we compute the functional values. So f of xl at the first iteration and f of xr at the first iteration. So f of xl1 will be equal to f of 0.2200, what have you. But note that from the question, our objective function is f of x is equal to x sine 1 over x. So that means wherever we find x, we put this thing there. So computing this is going to give us 0.0174349914. Okay. Then we have to compute XR at the first iteration as well. So that means wherever we find x, we are going to put this value there. And that is this. And when we compute that, you are going to get this thing here. So the step 5 says that we should evaluate L3, which is equal to L1 minus L2. So doing that is going to give us this. So this is L1, this is L2. So L1 minus L2 will give us this, which is L3. So after doing that, what we do is that we have to check to see if the stopping criteria is met. If it is not, then we have to continue with the iteration. So for the stopping criteria, it is the absolute value of xl minus xr should be less than epsilon. So you could see that xl was this, xr was this. When you take the difference and you find the absolute value of it, you get 0.0374541043, and you could see that that is not less than 0.001. It's not true, so we have to continue with the iteration. Okay, so we go on to the second iteration. So the second iteration, we have to choose new set of points, but we can only do that based on the functional values we had for xl and xr at the first iteration. So that of xl at the first iteration was this, and that of xr at the first iteration was that. Okay, so we can see that with these numbers that we have here, f of xr, the functional value there, is greater than this. Right, so we can see that f of xl at the first iteration was less than f of xr at the first iteration. I hope you can see that. So as a result of that, that means that the minimum coming, the function said we should find the minimum, right? So let's go back to where we got into. Okay, so since f of xl at the first iteration is less than f of xr at the first iteration, that means the minimum will be somewhere here. So you're going to have something like this. So that means you have to discard this region. So that means that our a2 will be a1 and our b2 will be xr at the first iteration. Okay, so we set our a2 to be a1, which is equal to 1 over 2 pi, and that is 0.15915494431. then you should know that B2 is equal to XR1, and that is 0.2574594668. Then from the algorithm which we've discussed, it says that when this condition is met, we set this to this, we set this to this, and also SR at the second iteration is equal to XL at the first iteration, which is 0.2200053625. Then we have to compute XL at the second iteration, and that is given by B2 minus L3. So this is B2, 0.2574594668, and this is L3. So computing this is going to give us 0.19665444249. Okay, so we have to compute this and compute that. So computing f of xl at the second iteration, you know, is the same as f of 0.19665444249. That means from the objective function, which is f of x equals x sine 1 over x. Wherever you find x, we put this there, and that is this. And computing this will give us what we can see here. So we do the same thing for xr at the second iteration, and that also gives us this 0.0174349914. So after doing this, we have to check to see if the stopping criteria is met. So you see, when we check SL squared minus SR squared, the absolute value of it will give us 0.023350936, which is less than the epsilon which was given in the question, 0.001. So that means we have to continue with the iteration again. So we have to continue with the iteration now until this condition is true, then we stop. Okay, and this is something that as a human being, if you are doing, you have to do thousands of iteration before you get that. So a computer can easily do that for us. Okay, but this was to explain the concept. So that's how we use the Fibonacci search method, okay, in optimizing unimodal functions. So if we try to continue, we'll do several iterations, thousands of them, before we can get the XL n minus XR, the absolute value of it being less than 0.0001. So thank you very much for following this video. So in our next lesson, that's in lesson 10, we'll talk about the golden ratio or the golden mean section search method. So thank you, and see you in the next video.